Ernest Rutherford was fond of taking the radioactive decay products of materials and firing them at other things just to see what would happen. When he fired them at a very thin foil of gold, he discovered something very important that tells us about the inner workings of atoms. In his gold foil experiment, Rutherford took a source of alpha particles, shown at the left, and shot the particles at a thin foil of gold atoms, shown as the gold spheres. The prevailing model of the atom was the raisin pudding model of Thomson. In that type of atom, there would be nothing hard or dense to stop the particles. Imagine throwing a baseball at a very thin wall made completely of raisin pudding. As you would predict with the baseball, he predicted the alpha particles would go straight through. Upon opening the source, he found that most did go straight through. There were some that deflected, as shown by the blue line. As a control, he also placed his detector next to the source, not expecting to see any alpha particles. However, a few, about 1 in 20,000, bounced back, as shown by the red line. How could this be if there was nothing hard or dense to stop the particles? Rather than a problem with the experiment, perhaps there was a problem with the model. Rutherford proposed what we now call the nuclear atom. Most of the atom was empty space. That is why most of the alpha particles went straight through. Most of the mass is concentrated in the nucleus, giving the atom a hard, dense part off which the alpha particles could bounce. The results of Rutherford's experiment necessitated a change in the model of the atom. We can trace the model from Dalton, who thought the atom was uncuttable, to Thomson, who realized that electrons were present but could not tell where the positive charge or the mass was, to Rutherford. In the Rutherford model, the electrons are still present and are free to leave, but the positive charge, as well as virtually all of the mass, all but the tiny amount carried by the electrons, are stuck in the nucleus.